All right. So yeah. So suppose a consumer is. So what is expected utility? Suppose a consumer has different outcomes with some probability. So let's say he can move to. He is making a choice between moving to either Bangalore or he can move to Kolkata. Okay. So in Bangalore, he has some high income HB with some probability PB and a low income LB with some probability P1 minus PB. And in Kolkata, he gets high income HK with some probability PK and low income LK with some probability 1 minus PK. So how is he going to compare between Bangalore and Kolkata? So one line of thought which originally was used was he maximizes expected income. That is what he will check is he will check PB times HB plus LB times 1 minus PB. So this becomes the expected income in Bangalore. And he will similarly compare HK times PK plus LK times 1 minus PK. So this becomes expected income in Kolkata. And the line of thought is that he will choose depending on a higher income. But that line of thought is wrong because when you are comparing between Bangalore and Kolkata, a bunch of other factors will come into play. For example, which city do you perceive to have a better living conditions? Then which city is maybe you have more friends in or more relatives in? So maybe you will want to avoid that city if you have a lot of relatives. That is sometimes a situation. Uh, Maybe some other considerations also come into play, like what could be your future prospects. So expected people are not expected income maximizers. So agents are not expected income maximizers. So what they are actually going to do is they are going to calculate expected utility. So expected utility of Bangalore is going to be PB times utility in Bangalore at HB level plus LB times, so 1 minus PB times utility in Bangalore at low LB level. Okay, this is a function. This is a function. This is not multiplication. Utility in Bangalore when you have income high Bangalore and utility in Bangalore when you have income low Bangalore. So compare this with this. Here the probabilities were multiplied directly with income levels. Here the probability is multiplied with the utility levels. So this was expected income. This is expected utility. And then you have expected utility Kolkata, which is going to be PK times UK into HK plus 1 minus PK times UK into LK. So you are going to compare these two values and check which of them gives a higher expected utility. All right, so this is what people are going to do. They are going to be expected utility maximizers. So when you are faced with uncertainty, you are going to be agents are generally going to be expected utility maximizers. All right. Uh, then there's a class of games which are called fair games. So fair games are the ones in which expected utility of a game is zero. Okay, or expected outcome in general is zero. For example, suppose you have a bet over coin toss. Heads wins you 1 rupee, whereas tail would make you pay 1 rupee. So the expected utility is, suppose my utility is directly proportional to how much money I have. Then with half probability, I win 1 rupee, and with half probability, I lose 1 rupee. Okay, so the net expected utility is going to be 0. So this is a fair game. All right. So expected utility of x is given as, sorry, the expectation of x. This is the, yeah, sorry. Okay, I have defined. So expected utility of different outcomes on the random variable x are summation pi I xi, where xi is utility from outcome I. So this part is your utility from outcome. Outcome means state of the world, outcome I. And pi I, this pi I is the probability of outcome I occurring. So it's basically the same thing that we did here. So here outcome B had utility UBHB. Sorry, outcome H in Bangalore had utility UBHB and the probability was PB. So probability times utility is the summation. That is going to be your expected utility. So here's a reason why agents don't actually optimize, maximize expected income, but they maximize expected utility. So consider a lottery. So this is an example, not a proof. So consider two lotteries. Lottery one gives you 100 rupees if heads and 10 rupees if tails. And lottery two gives you 100 if head and 10 if tails. So if you had an option to play one of these lotteries, suppose both lotteries cost you equal amount of money, you would play lottery one, right? Because expected income from lottery one will be equal to 100 by 2 minus 10 by 2. So that is 45. And expected income from lottery 2 would be 10 by 2 minus 10 by 2. So that is. So this is the problem. So initially what people thought is, so if you ask any person which lottery would you play, everybody would say lottery 1. So initial economists thought that what people are trying to do is maximize the expected income. So all the analysis was based on agents to choosing the option with highest income. But there was something fundamentally wrong here. So to show this, I'm going to use the St. Petersburg game, which is a very famous game. So in the St. Petersburg game, what happens is a gamble is proposed. So I'm proposing lottery 3. A coin is flipped until head appears. If a head appears on the nth flip, a player is paid 2 to power n. Okay, so if you get the first head, that's when the game will end. And when if it takes n trials to end the game, you will get 2 to power n. So if you get head on the first outcome itself, you will get 2 to power 1, which is 2. If you get tail followed by head, you'll get 2 to power 2, which is 4. If you get 2 tails followed by a head, then it took 3 trials, so 2 to power 3, so that is 8. And so on it goes. So what is the probability of this thing happening? What is the probability of getting a head in the first outcome? It's first toss you do, you get a head. What is the probability of that?
1 by 2.
1 by 2. What is the probability of getting a tail followed by a head?
1 by 4.
1 by 4. And similarly, this is going to be 1 by 8 and so on. Okay, so you see these numbers and these numbers. Now, if I want to find the expected income that you have after playing this game, right? So that would be 2 into 1 by 2. because you're getting 2 with probability half. You're getting 4 with probability 1 by 4 plus 8 into 1 by 8 plus 16 into 1 by 16 and so on. So this is 1 plus 1 plus 1 plus 1 plus so on. So what is the summation of this series?
N.
N, actually infinite, not n, because the game is defined in such a way that it does not stop anywhere. Theoretically, you can take infinite amount of trials to do it. So your expected return from playing this game is infinite. So now, if you ask people which game would you play lottery 1, lottery 2, or lottery 3? People should pick lottery 3 because lottery 3 is giving infinite return. So expected income from 3 is infinite, which is greater than both these. But people would still pick lottery 1. People are still going to pick lottery 1. The reason is that even though expected income in lottery 3 is infinite, the probability with which you get that very high income is very low. Here you are getting 100 rupees with probability half. Whereas here, the probability of getting at least 100 bucks is going to be too low. Okay, so if you continue like this, you'll have 2 plus 4. Okay, so probability that your income in lottery 3 is greater than or equal to 100. What is this value going to be? This is, you all understand lottery 3 now. So my question is, what is the probability that your return from lottery 3 would be greater than or equal to 100? This will require you to add a geometric progression.
So it will take at least 100 trials.
No, I'm asking the probability. So the sequence goes like this, okay? 2, 4, 8, 16, 32, 64, 128. So if the first 6 trials are tail, then you are getting something greater than 100 at least, right? If the first 6 trials are tail, because as soon as you get ahead, the game is over. So the first 6 trials must be tails. So that should at least happen. So the probability that the first 6 trials are tails is 1 by 2 to power 6. So that is 1 by 6. So with 1 by 64, the first 6 trials are tails, and you, so with that probability, this is the probability. After that, whatever happens, if you get head here, you get 128. If you get tail followed by head here, you get 156. Whatever happens after the first 6 trials are tails, after that, whatever happens, you are going to get at least 100 bucks in your income. So the probability of that is 1 by 64. Okay. Uh, okay, cool. So these things probably will get clearer after we do statistics, probabilities, and all those things. Okay, so you see, the probability of getting at least 100 bucks is 1 by 60. Whereas in lottery 1, you are getting 100 bucks with half probability. So obviously, you don't want to take this high risk game, lottery 3. Lottery 3 is a very high risk game. You don't want to do that. So here, the reason also relies on the fact that you have the consumer who is risk averse. So we'll look at risk aversion and what that means. subsequently in this particular chapter. But that's the idea. That's the idea. Okay, St. Petersburg paradox empirically laid it down that people are not picking lottery 3, even though it's giving a infinite expected return. So there is something more than just expected income maximizers, and the answer was hidden in utilities, that people are actually expected utility maximizers. Okay, payoffs. So in general, we are going to use the payoff in order to denote the thing that any agent is maximizing. So if you're talking about a consumer, payoff, it means utility. If you're talking about a producer, payoff means profit. If you're talking about, let's say, a politician, payoff is number of votes that he gets in an election. So different agents are going to maximize different things. The thing which is being maximized in any context will be called a payoff. So it's a generic term. All right, let's look at this example now. So suppose a farmer with a unit land has to choose between growing wheat and rice. While wheat productivity is 3 QW if it rains and 2 root QW if it does not rain. Okay, so if it rains, then wheat productivity is 3 QW. And if it does not rain, R bar, then wheat productivity is 5 root QW. The rice productivity, on the other hand, is 10 QR, 10 QR if it rains, and 2 QR if it does not. Here, QW and QR represent area under wheat and rice cultivation respectively. So he has a unit of land. He has a unit of land. So let's say this is his land. So he has to decide how much area to grow wheat in. So let's say he decides, okay, in this much area I'll grow wheat, and in how much area to grow rice. So he decides the remaining area goes for rice cultivation. Obviously, you not using any land is not an option, because we are not assuming any costs of cultivation. Here we are assuming there is no cost of cultivation. The farmer will divide his land between the two crops so as to maximize the total output. So total output is W plus R. So that is his total output. This is what he wants to optimize. All right. So everybody gets this problem. Uh, so if this area is QW, that is wheat, the remaining area 1 minus QW is the rice area QR. So you have a relationship on QR and QW that they are both less than 1, and QR is going to be equal to 1 minus QW. Okay. Rityan, for the given value of Q, okay, so you know that both QR and QW, they belong to 0 to 1, right? So which of these things is going to be larger? 3 QW or 5 root QW, which is going to be larger?
So 5 root QW.
Very good. 5 root QW is going to be larger, because for values between 0 and 1, root x is greater than x. All right. For values greater than 1, you have x greater than root x. All right. So if I were to draw the graph of x and root x between 0 and infinity, so this would be the graph of x, whereas the graph of root x will look like this, and they intersect at 1 comma 1. So this is your root x and this is your x. Okay, this is the graph for x. All right, so wheat, for any given value of QW, wheat productivity is higher if it does not rain. And for any given value of QR, rice productivity is higher if it rains. So the idea is that if he were to know for certain that it is going to rain, then he would prefer rice because then 10 QR is greater than this thing. But if he were to know that it is not going to rain for certain, then this thing will be larger because 5 root Q is greater than 2Q, right? So he's going to plant completely wheat if he knows for certain that it's not going to rain. And he's going to plant the complete field with rice if he knows for certain that it is going to rain. But the problem is that he does not know this with certainty. What he knows is that it rains with probability 0.4. So the probability of raining is 0.4 and probability of not raining is the remaining probability, that is 0.6. All right, so let me copy this thing. This copy. And let's work this out. So what he's going to do is, I know that QR plus QW is equals to 1. So what I'm going to assume is that QW is equal to some value Q. So QR becomes 1 minus QW, which is basically 1 minus Q. So I can now reform this table. So this table would become, when it rains, it becomes 3Q. For wheat, for rice, it becomes 10 times 1 minus Q. And when it does not rain, wheat is 5 root Q and rice is 2i's into 1 minus Q. Okay. The probability of raining is 0.4. The probability of not raining is 0.6. So now he's going to maximize expected utility. What is his expected utility? His utility, first of all, is W plus R. So this is what he's going to maximize. So the expected utility is probability of raining into utility when it rains plus probability of not raining into utility when it does not. Now probability of raining is 0.4. Utility from raining, when it rains, look at this column. So it's 3Q plus 10 times 1 minus Q. Plus probability of not raining is 0.6 times 5 root Q plus twice into 1 minus Q. Okay. So now expected utility is completely a function of a single variable, and that is Q. So now I want you to maximize expected utility with respect to Q. So find del expected utility by del Q equals to 0. Find the value of Q for which this first order becomes equal to 0. So we have all done a lot of differentiation by now. So please differentiate and tell me what's going to be the value. Give me the value of Q for which this thing becomes 0. This first order becomes 0.
So is it 0.14? Yes, sir, I'm getting the same.
Okay, let me see. 9 by 25. It's 9 by 25. So this is the solution. Okay, wait. Okay, I made some mistake. Okay, rice productivity was 10 root Q. Anyway, you did it for 10 into 1 minus 2. So let me check. So that gives an additional homework for you guys. Just make sure that you get this correct for 10 root Q as well. So do the entire thing for 10 root Q. I will solve this here for the question that I have elaborated to you for. So let me differentiate. So when I differentiate with respect to Q, I get 0.4 times 3. Okay, so this just, yeah, okay, 3 minus 10 plus 0.6 times 5 by 2 root Q minus 2. So this should be equal to 0. So this implies 0.6 into 5 is 3 by 2 root Q minus 1.2 minus this becomes 7. 7 into 0.4 is minus 2.8. Right? So this should be equal to 0. So this implies 3 by 2 root Q must be equal to 3. So I get root
So
Q.
that's 4. 2.8
Oh,
plus
yeah,
1.2 is
4. So root Q is 3 by 8. So Q equals to 9 by 64. Right?
Yes, sir.
Okay, so it should be 9 by 64. Is this what you guys got? 9 by 64?
Yes, sir.
Okay. So I've done this for a different one. So I usually give this as homework and this as the one I do in class because I've already given solutions. So I like to do this in class and the other one which I just did, I do it as I give it as a homework. I've done the homework. So you guys make sure that you do this one completely. Okay, don't look at the solution, try to do it completely on your own. So the idea is he's going to plant 9 by 64 of his field with wheat. So 9 by 64 is roughly 1/8. So in his given field, he is going to plant 9 by 64 with wheat, and the remaining 55 by 64 goes to rice. Okay. Obviously, with some different probability values, this will change. Okay, so one homework would be what happens for this case. For this case, what happens to Q if probability of rainfall was 0.6 now? So if rainfall has a higher chance of happening, but an intuitive question to you guys is, if rainfall's probability increases, will he plant more wheat now or more rice? Just answer this intuitively. So I know that for probability of rainfall 40%. So for 40% chance of rainfall, he plants 9 by 64 with wheat and 55 by 64 with rice. So my question is, if probability of rainfall increases, will he plant more wheat or will he plant more rice? Just intuitively, what do you think will happen?
Some more wheat.
Okay, which of these crops, according to these numbers, is giving a higher yield when it rains? When it rains, which of these crops is giving a higher yield? Don't look at Q, look at QR. Okay, rather look at these numbers. Which crop is giving a higher yield when it rains?
Rice.
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 So if I increase the probability of raining, which crop should do better?
Rice.
Rice. So you should increase the area under rice, not under wheat. Okay. So the area under rice should increase. Uh, so you should see this 9/64 decreasing. So that is an intuitive thing. Okay, you need to think intuitively as well, because in the exam they can give you as a two-part question. In first part they ask you this 9/64. In second part they ask you the same thing, but now with probability 0.6 for raining, and the options are, let's say, one option is 11/64, option B is 10/64, option C is 9/64, and let's say option D is 7/64. Suppose this is the QW that they are asking. Beat area. So I know that QW should be lower than 9/64. I don't know if 7/64 is the correct answer or not. I'm just giving you a hint of how to approach an objective problem. So you know these two options are greater than 9/64. They cannot be true. 9/64 cannot be true because the actual wheat cultivation should go down from 9/64 now. So the only possible option is option D, which is 7/64. So you don't even need to solve it now. Okay, so intuition can be a big help if you apply it correctly. It can save a lot of time in exam, and then you can devote this time to other questions. So that's an intuition. Let's do a more complicated problem now. A farmer can sow rice or dal in his 1 unit farm. While heavy rains help rice production to go up from 5 QR to 10 QR. So with with rainfall, rice production is 10 QR, but without rainfall, it is only 5 QR. It reduces productivity of dal from 5 QD to 10 QD. So dal production is 2 QD when it does not rain and 5 QD when it rains. Assuming that the rains are heavy with probability 0.5, so this probability is half, so this probability is also half. And the utility function is min of r comma t. So now utility is min of r comma t. So suppose this guy is producing for his own consumption and he likes to consume dal chawal in a fixed proportion. Ek katori dal, ek katori chawal. Okay, he only wants to consume them in equal proportions. That's the utility. So if you give him 2 katori dal and 1 katori chawal, he'll eat 1 katori dal, 1 katori chawal, he'll throw away the extra dal. Alright, so is the question clear to everyone? So now how the farmer should divide his farm between the two crops. So now the utility function is not a simple total output of rice plus dal. It's min of r comma t that was trying to optimize. So let me copy this table. Again, he has a unit of land, so I know that QR plus QW must be equal to 1. So I'm going to assume that QR is Q. So QW becomes 1 minus 2. So if I draw this table again, rice productivity is Q. So rice productivity when it rains becomes 10Q, and when it does not rain becomes 5Q. And dal productivity when it rains becomes twice into 1 minus Q, and when it does not rain becomes 5 times 1 minus Q. Okay. Now utility is min of R comma R comma. So what he is going to optimize is he's going to optimize his expected utility, which is basically probability of rain into expected utility when it rains plus probability of not raining into expected utility when it does not rain. Right? So this would become half. Both these numbers are half, 0.5 each. Right? When it rains, the utility is min of utility from raining is min of 10Q comma twice into 1 minus Q plus half times min of when it does not rain, these two numbers 5Q comma 5 into 1 minus. Okay, now I'm going to ask you guys a bunch of questions which is going to help me solve this. Okay, Ananya, what are the possible values for Q? Very easy. What is the possible values for Q?
So from 0 to 1.
Very good. Okay, so the entire line. Okay, who's next? Kanishka. When does this function report 10Q as the smaller of the two entities? When is 10Q? When is min of 10Q comma 2 twice into 1 minus Q equal to 10Q? That is what I'm asking.
So when 10Q is less than 2, 1 minus Q.
And which is what value of Q? What values of Q will satisfy this? So you are saying correctly when 10Q is less than twice into 1 minus Q, which implies what on Q values? Because I have this range on Q values. Now I want to find out.
So when Q is less than 1 by 6.
Very good. Okay, so this is 1 by 6. So for Q values between 0 and 1 by 6, let me call this as function 1, F1, which is expected utility when it rains. So here you would have F1 equals to 10Q, and here you would have F1 equals to twice into 1 minus. Okay, next, Kritika. When will this function
Yes.
report 5Q as the minimum?
When Q is less than 1 by 2.
Very good. Okay, so this is 1 by 2. So here F2 will be equal to 5Q. And in this region, you will have F2 equals to 5 into 1 minus. Okay. So I actually have three zones between 0 and 1 by 6, between 1 by 6 and half, and between half and 1. So in the first region, I have F1 equals to 10Q and F2 equals to 5. In the second region, I have F1 equals to twice into 1 minus Q and F2 equals to 5. And in the third region, I have f1 equals to twice into 1 minus q, and f2 equals to 5 into 1 minus q. Right? Now, expected utility is equals to half times f1 plus half times f2, because f1 is expected utility when it rains, f2 is expected utility when it does not rain. All right. So next, who's next? Nanika. What is expected utility in this region, in region 1? Just add up this formula. Yeah, just add up this formula and tell me the expected utility.
Sir, half of 10q plus
Yeah.
half of 5q.
Which is what? Can you simplify it further?
So the probability plus the utility.
No, forget probabilities and everything. This is f1, this is f2. What you have said is correct. Half times 10q plus half times 5q. Can you simplify it further? Forget probabilities and everything. This q is some random variable which you don't know right now. Just give me,
Sir, half of 10q plus 5q.
which is what? The most simplified version that you can put for this. Can anybody else help Nanika here?
So 7.5 Q.
Very good, 7.5.
Hmm.
Okay, do you understand, Nanika, what I was asking for?
Yes, sir.
Okay, what is expected utility here, Yuvakshi?
Sir, 1 plus 3 by 2q.
1 plus 3 by 2. Perfect. Okay. And finally, I have Nityan. What is the expected utility here?
एक मिनट सर कैलकुलेट नहीं किया गया.
Also, you need to speak up a little. I think you are very far away from the mic, maybe.
Sorry, sir. 6 minus 2q.
I'm just asking, these are your F1, F2, and this is your formula for expected utility. Q is not, Q is a random variable.
Half, sir. Half into 2 into 1 minus q plus half into 5 into 1 minus q.
Which is what?
So,
Can you give an easier version of the answer?
6 minus 2q.
6 minus
2q.
doesn't seem right. So this is basically 1 minus q becomes common, right? Half into twice into 1 minus q plus half into 5 into 1 minus q. So you can take 1 minus q common, and this just becomes 7 by 2 times 1 minus q, which is 3.5 times 1 minus q. Right? Okay. All right. So now you have the expected utility formula for the 3 regions. And I have my 3 regions here. So Q goes from 0 to 1. Okay, region 1 is between 0 to 1 by 6. Region 2 is till half, and then there's third region. Here the expected utility is 7.5 Q. Here the expected utility is 1 plus 1.5 Q. And here the expected utility is 3.5 into 1 minus Q. So if expected utility was a function of just Q, forget expected utility. Just think of this expected utility as some f of Q, some function f of Q. So you have your f of Q function, which looks like this in 3 different regions. Optimize this over the domain 0 to 1. Optimize f of q. What is going to be the maximum value of f of q? Guys, hello. Can you guys hear me? It's not so difficult. You can plot this function, by the way. These are all linear curves. It's linear everywhere. So you can plot it. Okay, so let me proceed like this. Okay, Ananya, what is f of 0?
Sir, it's 7.5 Q.
What is that if I put q equals to 0? I'm asking for very specific answers here.
Sir, 0. It will be
Okay,
0.
I'm asking for, I know it's 7.5 q here. I'm asking very specific answers. All right, so please try to be specific, as specific as you can. So I know that f of 0 is 0. So the function will start from here. Okay. Next, Kanishka, is f continuous at 1/6?
So I'm calculating.
Okay. All right. What is f at 1/6 minus? Kanishka, what is f of 1/6 minus?
So 1.25.
1.25. Okay, so it's going to be just 7.5 divided by 6. So that is 1.25.
Yes, sir, it is
Yeah.
continuous.
Okay, fine. So how do I check continuity? I check f of 1/6 minus, and then I check f of 1/6 plus. So maybe Kanishka has already done it. So that is going to be 1 plus 1.5 into 1/6, and that is also 1.25. So around 1/6. To the left of 1/6, the function is 1.25. To the right, it's also 1.25. So it's continuous. So it will look like this. Okay, after this, it is continuous. Kritika, is the function continuous at half?
So I'm calculating.
When you calculate if it is continuous, also tell me f of half. Okay. Next, Nenika, what is f at 1?
Sir, 1.
Why 1? What is the functional value here? What is the formula of the function here?
So 3.5 into 1 minus q.
So what happens when you put q equals to 1 here?
So it will be 0.
So why did you say 1? It is 0, right?
Yes, sir.
All right. So
Yes.
Don't give me blind answers. I'm writing stuff on the screen for you. Ideally, you should have it in your notebooks and then you should be giving me, but I know how online teaching works. You don't have, maybe you don't have it, you haven't written it or whatever, but it's there on the screen. Whatever you need, it's there on the screen. All right.
Yes, sir. It's continuous at 1 by 2.
What is the value?
1.75.
1.75. Okay. So this is 1.75. All right. Duvakshi.
Yes, sir.
Okay. What is this? So you see, this is linear, this is linear. What is the slope in this section for the function? What is the slope of the function here? Obviously, since it's continuous, it needs to go down, but what is the slope of this function? What is basically f prime?
Minus 3.5.
Yeah, minus 3.5. Okay, minus 3.5. Anyway, so this is how your function looks like now. Okay, so all of you can see the function. So now the final question is, what is the optima? What is the maxima of this function and what value of q will it happen at? You have the complete graph now. You do not need anything
Sir, at
else.
1 by 2.
And what is the value?
1.75.
1.75. Very good. Okay, so this is how you can do it. I actually did not need to do it. All I needed to do was check if it is continuous at these 2 points. And once I know it is increasing here, it is increasing here, and then it is decreasing. So I know that it will have its maxima here at half. I don't need values. I just need to check for continuity. Checking for continuity is important. Okay. And generally, min functions will turn out to be continuous. So if you, right now I'm asking you to check for continuity, but in exam, if you get a function like this, you can ignore continuity altogether. Because yes, it will, you ignore checking for continuity, not ignore continuity. Sorry for the wrong words. You can ignore checking for continuity because min functions, they turn out to be continuous. They are not differentiable, but they will turn out to be continuous. So you don't need to waste time in an exam checking for continuity. You can directly, once you get this function, f function, you know that it is increasing here, then it starts reducing. So the optima should happen at half. So the maximum will be at half. So that's how you would do it in an exam if it came in objective. If it comes in subjective, I don't know, maybe you'll have to check. Show all these steps. If you have time, definitely show all these steps. If you don't have time, ignore continuity. Just show that the function, just say that the function keeps on increasing till half and then it is decreasing. So the optima happens at half, that is maxima happens at half, and then it gets back. Leave one page, maybe come back to it later if you have time and prove continuity. Out of 10, I would give 8 marks if you reach this solution without continuity. If you show continuity, I'll give you full marks. Okay, maximum I'll deduct 1 marks for ignoring continuity. So if it takes time, don't show continuity. If you have time, show that. All right, next up we have intertemporal model. Yeah. So in intertemporal choices, till now, what we have done is we said that the consumer has some income and he spends this entire income. It felt wrong and it is wrong. All right. I would never spend my entire income. Okay, you guys give me fees. It's not like I end up spending it right away. I save it. I save it because I don't know, the future is uncertain. I save it for the future. I know I might not be earning in the future. I want to retire after some time. And so that's the reason I don't spend my entire income. That is because I live for multiple periods. And the word multiple periods is written as intertemporal in English. Okay, temporal means time related. Intertemporal means across time period. So intertemporal choices is when a consumer is choosing to spend his income in multiple times. So let's say somebody is born rich with a lot of inherited money, in lot of inheritance. He decides not to work. He just decides, okay, let me spend this across my lifetime. So how should I spend this money? So suppose he's born with 100 million rupees, or let's say 1 billion rupees. So he decides how to spend this 1 billion across my lifespan of 70, 80 odd years. Whatever that is. So what is the model here? The model here is that the household lives for 2 periods with utility function C1 comma C2. So we'll have different models here. Sometimes the consumer will be earning in the second period. Sometimes he's earning in the first period. Sometimes he's not earning anything. He just has some inheritance to be born with. So you will have multiple sort of situations. So we'll lay down the basics. And once we lay down the basics, you should be able to handle any situation that comes. So a household lives for 2 periods with utility function, this one, where C1 and C2 are consumption levels in period 1 and 2. So C1 and C2 are consumption levels. Okay, so this is the actual amount of consumption that you do. And delta is the discount factor. So delta will be between 1 and 0. So it's basically you're going to discount future utilities. Now, why does the discount factor happen? So one of the reasons is you do not know if you're going to live tomorrow or not. Okay, so you discount the probability of tomorrow happening at all, right? The other thing is that like zindagi na milegi dobara. Okay, so I don't know. I mean, you don't know if you're going to live for a very long period or not. Okay, so that's one reason. The other reason is the inherent nature of human beings is instant gratification. People are generally they want, okay, if I'm getting something I want it now, why should I wait longer? So utility tomorrow is not the same as utility today, even if you were certain of surviving till tomorrow. Even if you know the future that you're going to survive, even in that case, why wait for something till tomorrow if I can get it today? So that's why future utilities are discounted. In any case, nobody is going to ask you the theoretical background for discount factors. Everybody is going to give you a discount factor and it will be between 0 and 1. Okay, it will always be between 0 and 1. The incomes are Y1 in period 1 and Y2, which can be positive or 0 in period 2. So in period 1, you are getting a positive income. In period 2, maybe you get a positive income or maybe you get no. The household can save some of his income in the first period and some of his initial rent. So you have the possibility of saving some income. So your entire income in period 1 gets divided in consumption in period 1 plus some amount of savings, such that C1 plus S must be equal to your income. So that becomes your period 1 budget constraint. PC1. So period 1 budget constraint is C1 plus S equals to that. Now in period 2, this savings, you get a return on this savings. So this becomes X into 1 plus R. You put it in a bank, you get a return, plus you get some Y2 amount of income in period 2. These two together, they become your consumption in period 2. So these two form your consumption in period 2. So consumption in period 2 is income in period 2 plus whatever savings you have plus interest. So this is budget constraint in period. So this is all standard, pretty standard. Summing both budget constraints, we get, so if I eliminate S from this, so equation 1 is Y1 equals to C1 plus S, which implies S equals to Y1 minus Equation 2 is C2 equals to Y2 plus 1 plus R into S, which implies S equals to C2 upon 1 plus R minus Y2 upon 1 plus R. So look at equations 1 and 2. The left hand side is same, so the right hand sides must also equate. So what I should get is Y1 minus E1 must be equal to C2 upon 1 plus R minus Y2 upon 1 plus R, which implies Y1 plus Y2 upon 1 plus R must be equal to C1 plus C2 upon 1 plus R. So this is your intertemporal budget constraint. Now this formula is very important. If you have a person living for n periods, what you will get is y1 plus y2 upon 1 plus r plus y3 upon 1 plus r square plus y4 upon 1 plus r4 and so on till yn upon 1 plus r to power n minus 1. Okay, so these are some small things in which you can make a mistake. Okay, so sorry, this should be
Sir?
R2. Yeah, yeah, yes, Nitin.
सर मैं यही पूछने वाला था
What?
सर मैं यही पूछने वाला था 1 plus r to the power cube.
I can't hear you clearly. Can you please speak up, Nitin? Can you speak closer to the
Sir.
mic? Yeah.
सर 1 plus r to the power cube यही बोलने वाला था.
Okay, okay. So this n will not happen because you see, coming from here, y2 gets divided by 1 plus r to power 1. Y3 gets divided by 1 plus r to power 2 and so on. So you see, there is a factor of 1 difference between this coefficient and this power. So here, when you reach nth period, you are going to only divide it by n minus 1. This thing is your present value of total income. What is present value of total income? So assume a person living in n different periods. So this is his income y1, this is y2, this is y3, so on till yn. Suppose in today's time, I want to take a loan against income tomorrow. So I'm saying, yaar, I need money today. I'm getting y2 income tomorrow. Please give me some money. So the maximum amount of loan that you can withdraw on the basis of being able to generate an income y2 in the next period is going to be y2 upon 1 plus r. So today, based on the fact that you are earning y2 income after one period, somebody is willing to give, the bank is willing to give you y2 upon 1 plus r. Because if you take a loan of y2 upon 1 plus r today, after interest of r, you will have to pay back y2 amount in the next year. Similarly, against this y3, if you want to take a loan, the maximum loan you will get today is y3 upon 1 plus r whole square. Okay, so this y3 upon 1 plus r whole square is the present value. No, this y3 upon 1 plus r whole square is the present value of period 3 income. This is the present value of period 4 income and so on. So this entire summation is the present value of your entire future income. Okay. Similarly, this C1 plus C2 upon 1 plus R is present value of all consumption. So what you do is by dividing with 1 plus R times something, you are calculating the present value of a future income or a future consumption in today's terms. If you were to take a loan against a future income, how much loan can you generate for against it? So that is the present value of income. So budget constraint, the intertemporal budget constraint is nothing but present value of income equal to present value of consumption. So these two things, this should be 1 plus R, 1 plus R, I underscore 1 underscore R, this should be 1 plus R. Okay, so this is your present value funda. Now, how does change in interest rate impact your consumptions in the two periods? So this comparative statistics is important. They've asked questions in past year based on this. So I think even this year they asked a question based on this in ISI. I'm not sure why, but you will see when you do the past year, you'll see. Okay, so income effect. So if so, yeah, just on the basis of this budget constraint, you know that C1 plus C2 upon 1 plus R must be equal to Y1 plus Y2 upon 1 plus. So what you can do is you can basically think of C1 and C2 as not consumption in two different periods, but rather consumption of two different periods. This is your net income, present value of income I. And you can assume that 1 upon 1 plus R is nothing but the price of consumption in period. Okay, so if you now again look at this equation, this becomes C1 plus P2 times C2 is equals to income. So this is the same as the budget constraint in any particular period across two different commodities. So let's say you are consuming just one good, which is let's say pizza. You are consuming pizza today and pizza tomorrow. So in intertemporal, we say that pizza today and pizza tomorrow can be considered as two different commodities in the same period. So the same commodity in two periods becomes different commodities in the same period. All right. So if you expand it across 3 time periods, so pizza today, pizza tomorrow, pizza day after tomorrow, these 3 commodities become 3 different goods. You have your total present value of income. Across this present value of income, you are going to optimize the consumption of these 3 different goods. The good is same, but it is across 3 different periods. So we try to think of it. We are basically removing the variability of time and introducing variability of consumption, so that we can use the same logic that we used in case of same time period consumption. Right? So all the logic that we used back then now becomes available to me, because instead of assuming consumption across time periods, I am saying consumption in the same time period but across commodities. Right? So does everybody understand the beauty of this? I have made the maths same as what we did in consumer theory. There is no difference, absolutely. So all the income effect and substitution effect will come into picture now. So if a saver, so what is the income effect? So now price change in P2 is basically change in R. So P2 is basically 1 upon 1 plus R. Right? So if R increases, it implies P2 reduces. So if your rate of interest increases, it's same as your price reducing, price of second commodity reducing. So remember that in consumer theory, we looked at how change in prices can be broken down into income and substitution effect. So here I'm going to look at income and substitution effect for change in interest rate R. So if you're a saver, then higher interest rate increases income for a given amount of saving, which increases consumption in the first and second period. So if you're a saver, then what happens is your saving is positive. So your Y1 is C1 minus S, your Y2 is, sorry, your C1 is Y1 minus S, your C2 is Y2 plus uh, S into 1 plus 5. So higher interest rate increases income for given amount of saving. So if interest rate increases and you don't change savings, then your consumption in period 1 is same, whereas your consumption in period 2 increases, right? So what you can do instead is you can reduce savings by a little bit. So if rate of interest goes up, you can reduce savings by a little bit, so that this reduces by a little bit, so that consumption increases, and at the same time consumption period 2 also increases. So you can increase consumption in both periods by if your rate of interest rises, right? So that's what this is saying. So increases income for given amount of saving. So your total income will rise for a given amount of saving. An increase in interest rate will increase your total income, which increases consumption in first and second period. So income effect for good 1 is positive, and income effect for good 2 is also positive. Now substitution, okay, for a borrower, income effect is negative. So by the same logic, for a borrower, income effect is going to be negative for both consumption C1 and C2. Okay, so this is for a saver. For a borrower, income effect is negative for both groups. Now coming to substitution effect. So the gross interest rate 1 plus R is the relative price of consumption in period 1 to consumption in period 2, like we talked about here. Now C1 becomes more expensive related to C2. So if R increases, P2 reduces. If P2 reduces, it means good 2 is becoming cheaper. So good 1 is becoming costlier. So by the substitution effect simply says that you substitute the cheaper product in place of the costlier product. So you reduce the consumption of the costlier product, you increase the consumption of the cheaper product. So C2 should increase and C1 should reduce. So the substitution effect is always for both a borrower and a saver, you have substitution effect of good 1 as negative for an increase in interest rate, and substitution effect for good 2 is positive. Okay. So let's analyze a saver now. So for a saver, income effect of good 1 is positive, substitution effect is negative. But income and substitution effect for good 2 is positive for both the guys. So for a saver, IE2 positive and substitution effect of good 2 is positive, which means that if interest rate increases, consumption in period 2 increases. So for a saver, if interest rate rises, you will see consumption in both the periods rise. Okay. Now for a borrower, You see income effect negative here, substitution effect negative here. So consumption in period 1 will definitely reduce. You have both the effects negative. But for good 2, you cannot compare. They are going in different directions. So I cannot compare. So if you are a saver, if you are saving in first period, then if rate of interest rises, your consumption of good 2 will rise, whereas your consumption of good 1 can go either way depending on which of these quantities is larger. Is income effect of good 1 larger, or if substitution effect of good 1 is larger. Whereas for a borrower, you will see the opposite happening. So the idea is, why is income effect positive again for a saver? So for a saver, if you're saving money and interest rate rises, your overall income rises, right? Because in the second period, your income is coming back as savings. But if you're a borrower, the income effect is negative, because if rate of interest rises, you cannot take a big amount of loan, right? Because you'll be paying much more interest rate. So your overall income reduces. So the income effect is negative for a borrower for both the companies. Okay, so you can remember this simple logic and this substitution effect thing. So if you can do that, you will be good with any sort of example which comes in. Okay, so this entire thing is important. This substitution effect and income. Okay, so I am going to star mark. I have already star marked this comparative statics. Okay, so this is important. It's been asked earlier, and I want you to be good at it. Okay, let's do an example quickly. We have 5 minutes. We'll do one example. The next example, I'll leave it to you guys. So suppose an individual lives for 2 periods, 1 and 2. He earns an income I in period 1, which he can either save or consume. His savings in period 1 can then be consumed in period 2. So his Y1 is I, his Y2 is 0. He can buy good X in either periods at price P. If his utility function is utility equals to under root x1, x2, where x1 is consumption in period 1 and x2 in period 2, how much will he save in period 1 so as to maximize his? Okay. So there is no rate of interest mentioned here. So what I'll see is that consumption in period 1 is income in period 1, which is basically I minus S. And consumption in period 2 is equals to, there's no income in period 2, so just S. When I add these two equations, what I get is C1 plus C2 must be equal to I minus S plus S, so that is equal to I. Okay. So X1 is equals to C1 by P, and X2 is equals to C2 by P, which is I minus C1 by P, which is I by P minus X1. So X1 is C1 by P, X2 is I minus P minus X1. So utility can be just written as X1 into X2 is just I by P minus X1. Okay, in alternate terms, you can write I by P as your, what is I by P? Anybody awake till now? What is I by P? Income divided by prices. What is income divided by prices? Has nobody learned?
X1.
No. I'm
So
talking the economic.
total units of the good that we can buy.
No, I'm asking the economic meaning of I by P. Income by prices.
So demand
What?
function. The demand function, Marshallian demand function is sizable.
No, it's not such a big thing. I could not hear what you were saying. You need to work on your mic. There's some issue there. What is I by P? Has anybody heard of the thing called real income? Has anybody heard of real income? Has
Yes,
anybody
sir.
heard of real income? Yeah, so it's a pretty common thing. Real income. I by P is your real income. Okay, it's not, suppose price level is something P, I by P is the real value of your income. So yeah, you are correct. The maximum amount of X you can buy, but that is called real income. The economic term for that is real income. So X1 into I by P minus X1. So that is going to be your utility. Okay. Optimize this with respect to X1. But since we have a shortage of time and I know that you guys are working on your derivatives, so you must be good at it. So I'll just breeze through it. So this, when you differentiate this, but alternatively, what you can do is you can do a monotonic transformation. You can say this is u square. U square now becomes x1 into I by p minus x1. Okay, so this becomes x1 into real income r minus x1. And you can just differentiate this. So you, when you differentiate this, you get x1 equals to r by. This is the optima. X1 star equals to r by. R is real income I by P, so X1 becomes I by 2P. So savings become I by 2. So you're going to save half of your savings. Okay. So this is a simpler of the examples. The next example which you have to do on your own is going to be a little more complicated. So you do this example.